Namaste students. Now we will see what are the things to be remembered in the experiment, conversion of galvanometer into voltmeter. So you will be given a galvanometer. You have to collect some data from the galvanometer like galvanometer resistance, Rg, number of divisions in the galvanometer, its figure of merit, K. All those things will be written in the galvanometer. It will be given. So using those values, you have to find out the series resistance to be connected along with the galvanometer to convert it into voltmeter. You know the procedure and all. So values here, I have values. So better we calculate it once. So Rg value will be given in the galvanometer, figure of merit will be given, and number of divisions, how many divisions are there in the galvanometer, that will be given. You can see a galvanometer here, there are 30 divisions starting from 0 to 30 we have. So that galvanometer has to be converted into voltmeter. So getting all these values, you have to find out Ig, the current required to produce full scale deflection in the galvanometer. So if you want to make this needle to turn by 30 divisions, so to come here, what is the current required? That is called Ig. So if you want to calculate it, Ig is equal to N into K. Here you have the formula. Number of divisions in the galvanometer is 30 and current required to produce one division deflection is 10 point into 10 to the power minus 6. That is 306 into 10 to the power minus 6. So if I bring 3 places left the decimal point, then this will be 0.306 milliamperes. Or you can keep it like this also, no problem. Now, what is the series resistance to be connected in order to convert the galvanometer into voltmeter? V by Ig minus Rg. So you have to assume, or it will be given in the question paper, for how much range of voltage you have to convert the galvanometer into voltmeter. So it is given here, 3 volts. So the series resistance that has to be connected is V by Ig minus Rg. Here, one thing you have to keep it in mind, there is no 10 to the power here, but there is a 10 to the power, 0.306 into 10 to the power minus 3. When this 10 to the power minus 3 comes to the numerator, it becomes 10 to the power plus 3. That means 1000. It becomes 1000. 1000 into 3, that is 3000 by 0.306. That's what you have to do, minus 150. So don't neglect this 10 to the power. So when the 10 to the power minus 3, which is in the denominator, comes to the numerator, it will be 10 to the power plus 3. So here they have calculated it by just by bringing 10 to the power plus 3 to the numerator. They have divided 3 to 0.306, then multiplied by 1000. That becomes 9803 without any 10 to the power. That has to be subtracted with 150. So 9653. So in some of the experiments, the series resistance may be 4000 also. That depends on the galvanometer. If you get another galvanometer, the series resistance to be connected to convert it into a voltmeter of range 3 volt may be different. So accordingly, you will get this R. Once you get this R, you have got an idea that this is the range. Okay. So whether this theoretical value agrees with practical value. So how to do the practical now? How to see what is the series resistance to be connected? You have to have the connection like this, a battery here, and battery has to be connected in parallel with the rheostat. So we have a rheostat here. So you can see the connections given from the battery to the rheostat. All the connections are not seen. So here there is one more negative wire coming here. Then once, so it is coming from below here, right, like this. So, okay. Now, once this battery is connected to the rheostat, from the end where we have connected the positive of the rheostat, positive of the battery to the rheostat, from the same end, you have to connect to the galvanometer, from the galvanometer to the series resistance, from the series resistance to the variable end of the rheostat, that is this end. So from positive to rheostat, from the same end to galvanometer, galvanometer to resistance box to the variable end. And usually students commit a mistake here while connecting this voltmeter. So set the range of the voltmeter to 20 volt, and then positive end has to be connected to this point of the galvanometer from where you have got the positive of the battery. Positive of the battery from here to here you have got. From the positive, that end you have to connect it to the positive of the voltmeter. What about the negative of the voltmeter? Negative of the voltmeter to this variable end of the rheostat. You can see this here clearly. Here you see. So positive of the battery. So now I have to change the color. Okay. Positive of the battery to one end of rheostat, negative of the battery to another end of rheostat. Then once it is connected, then from the same end where you have connected positive, the galvanometer, resistance box, then variable. From positive of the battery end to the rheostat, you have to connect it to the voltmeter, positive of the voltmeter, either here or here or here, anywhere is okay. Negative to the variable end. So it has to go to the negative variable end. Okay. So once this connection is done, how to carry on with the experiment? It is done like this. So first what you have to do is, I'll remove all the unwanted things here. I'll change the colors also. Yeah. I'll go for some, yeah, yellowish color. Now, what you have to do is, initially this is infinity, you see. Yeah, the resistance R is infinity. Then set with R is equal to infinity, set battery, the voltmeter value, V is equal to 3 volt. Set V equals 3 volt. So what this battery has to be set, this one has to be set to 3 volt. And how you can, we will come to know that it is giving 3 volt. You have the voltmeter here. So this should show 3 volt with R infinity. So don't forget to set R equal to infinity. Set R equal to infinity. That means remove this key, which is the infinity key, open it, then rotate this battery potentiometer, that pot, or you can vary the rheostat till the voltmeter shows 3 volt. Once it is done, now introduce R. So remove some 5,000 or 4,000 or 9,000 approximate values, because already you have got the theoretical value. Remove such resistance, approximate resistance, then plug this infinity. So plug the infinity and remove some resistance. First you remove some resistance in the resistance box, approximate some 1,000 values, and plug this infinity. Immediately you will get the deflection in the galvanometer. But adjust this value of R such that this galvanometer shows full scale deflection, that is 30 divisions. So for 30 divisions, what is the resistance to be unplugged? That's what you have to find out. For 30 divisions, what is the value of R? That has to be recorded, and that should be very close to the value of R that you have calculated here. So initially set R is equal to infinity, set V equal to 3 volt, then not this one, this is wrong. For what value of R you get theta is equal to 30 divisions deflection. So till the galvanometer shows 30 divisions, what is the value of resistance to be unplugged? That should be very close to the value that you have got here, theoretical value. If it is 9,600, you may get 9,500, 800 like that. So that's how we verify it. And then finally we write that the theoretical value and the experiment values agree with each other. That's how we conclude the experiment. So very, very simple experiment, but you must work out these values and be careful about this 10 to the powers. Thank you.